Hello everyone, welcome to my NSX video series. For disaster recovery, if a disaster or unplanned outage happen, VMware has products such as Site Recovery Manager and vSphere Replication that can automate and orchestrate the recovery process during the failure from primary site to recovery site. Today, SRM recovers replicated virtual machine from a primary to secondary data center. SRM can perform network mapping and remapping between the primary and secondary location so that the recovered virtual machine can be reconnected to the appropriate network. Those networks can be VLAN back, distributed virtual port group, or NSX logical switch. NSX supports seamless spanning of network and security policies across multiple sites through the use of the Cross Virtual Center NSX feature introduced in NSX 6.2. NSX supports seamless spanning of network and security policies across multiple sites through the disaster recovery solution can also be built without leveraging Cross vCenter NSX by using an external replication synchronization mechanism, such as VRO, vRealize Orchestrator, to recreate logical network and security between separate NSX instances across the two sites. However, Cross vCenter NSX greatly simplifies this process. Deployment elements consists of universal logical switches, universal distribute logical routers, and universal distribute firewalls. Those universal objects facilitate the creation of a single unified logical network across protected and recovery sites. The application can failover and recover seamlessly without the need for manually recreating the network on the recovery site or manually mapping and remapping IP addresses. In this video we will address the most popular scenarios of partial failover of the application with minimum change to the network configuration and the full failover of the application in case of extended outage or catastrophic failure. We will review and configure NSX for multiple sites. In our case, we will refer to each site as the protected site and recovery site. We will configure SRM components including protection plan and recovery plan for the web-based 3-tier application. Then we will facilitate partial failover for maintenance purpose and full failover in the case of multiple components failure. First, we will do reviewing of the existing multi-site configuration for various components such as NSX Manager, vCenter Configuration, controller cluster, host preparation, logical network preparation, as well as configuration for Edge gateway on both sides. We will also walk through configuring routing between universal distributed logical routers and Edge gateways on both sides using Border Gateway Protocol (BGP). This picture shows the vSphere hosts and how VMs are placed across different clusters. You can also see VTP, VXLAN tunnel endpoint IP addresses associated to the hosts. Clusters Region AO1 Management and Region AO1 Comp are both managed by the vCenter Server A. Cluster Region BO1 Comp is managed by the vCenter Server B. Both vCenters are connected to Common Platform Service Controller that resides on the management network on the Region AO1. Here is also NSX Transport Zone. Region AO Transport Zone has a local scope for vCenter A and is available on both clusters of Region AO1. It's already pre-configured. Universal Transport Zone has a universal scope and is available on both vCenters. It's also already pre-configured for this environment. This picture presents topology we already have here, that's pre-configured. Here is 5 NSX universal logical switches: Web tier logical switch, App tier logical switch, DB tier logical switch, Region A01 transit switch, and Region B01 transit switch. The simple 3-tier application is already configured. The logical switches are attached to Universal Distributed Logical Router, which is in turn attached to the NSX Edge Service Gateway in each region. BGP routing guarantees route exchange between the Edge server gateways and the external router. In addition, vSphere replication is configured to replicate the 3-tier application VMs. CRM has also been pre-installed and configured with initial peering. This entire configuration is done in advance to concentrate on the actual use case we need to highlight. During this video we will configure elements shown in red boxes here, including configuring local ID on the recovery side, configuring internal BGP between Universal Distributed Logical Router and Edge Service Gateways on both the sides. We will also configure a BGP prefix list for filtering routes. This topology shows the environment after completing a partial application failover. In this case, the east-west traffic will be using local default gateway, whereas north-south traffic to the web VM, as shown, will ingress and egress out of protected site only. And finally, this topology shows the environment after performing a full application failover. North-south as well as east-west traffic will exist only in the recovery site. Let's take a look of Vcenter configurations. Here are the two vCenter servers, 1A and 1B. In this environment, two vCenter servers have been configured in the enhanced linked mode. This allows both vCenter servers to be managed through the same vSphere web client session, and also can share same identity provider. On NSX configuration on installation tab, note the rules assigned to NSX Manager. NSX Manager register on region AO will have the primary rule, and NSX Manager registered on region BO will have the second rule. Universal Controller Cluster performs the required control plane functions across both vCenter servers and their respective NSX managers. This enables the configuration of universal logical switches, universal logical routers, and universal distributed firewall rules. Here controller 1, 2, and 3 are connected to the primary NSX manager and peers are showing green. And also controller 1, 2, and 3 are connected to the secondary NSX manager. Let's review Universal Segment ID pool on the primary NSX manager. Before universal logical switches can be configured, Universal Segment ID pool must be created. Universal Segment ID pool must be a unique range from all other segment ID pools in use, on both NSX managers configured in a cross-vCenter environment. Note the different range used for Universal Segment ID pool. Switch to secondary NSX manager. The secondary NSX manager must also be configured with the segment ID pools. Segment ID pools configured on all NSX managers must be non-overlapping. Universal Segment ID pool is synchronized from the primary NSX manager. Let's take a look at universal transport zones. Transport zones define what clusters can participate in the specific logical network. Global transport zones are confined to a single vCenter server, until universal transport zones may span vCenter servers. We can verify that the cluster region BO1 comp is connected and in a normal status. Switch to primary NSX manager to check universal transport zone. We can verify cluster region AO1 comp and region AO1 management are connected and in normal status. Next, we will review pre-configured universal logical switches and create new universal logical switch. Universal logical switches are configured in the same tab as the global logical switches. We have 5 pre-configured universal logical switches. If we look at the secondary NSX manager logical switches, once configured, universal logical switches are synchronized to all secondary NSX managers. All switches are also available on the secondary NSX manager, as well their segment ID match those seen in previous step. Let's create a new universal logical switch. I will create them on a primary NSX manager. Universal logical switches are only configurable on the primary NSX manager. Then they are synchronized across the remaining NSX managers. I will call them NSX Universal Logical Switch. I will set Universal Transport Zone. Note please that replication mode is unicast. Okay, here's our new created NSX Universal Logical Switch. If we switch on the secondary NSX manager, we can find the same Universal Logical Switch and has been synchronized. It's time to see NSX Edge Configurations. In this environment, NSX Edge devices provide connectivity for north-south communication as well as east-west communication. There are 2 pre-configured NSX Edge devices for north-south communication. Those perimeter gateways are configured with dynamic routing utilizing BGP. The perimeter gateways utilize equal cost multipairing to allow traffic in and out of both sites. A third NSX Edge has been pre-configured as Universal Distributed Logical Router, providing east-west routing among the application logical switches, as well as connectivity to transit Universal Logical Switch on each site. For north-south communication to the perimeter gateway, Edge Services Gateways. This Universal Distributed Logical Router has been configured for ECMP and local egress. Local egress enables egress optimization per site. Traffic is routed through the ESG at the site the traffic originated from. East-west traffic utilizes the Universal Distributed Logical Router for optimization between VMs. This configuration requires dynamic routing between the physical network and ESGS, as well as between ESGS and Universal Distributed Logical Routers. The Universal Distributed Logical Router advertises the configured network to both ECGs. The ECGs advertise the Universal Distributed Logical Routers networks to both sites' physical network. This configuration allows the physical network to transmit and receive traffic to end from the same network at both sites. Traffic originating from region EO VMs agrees the local network through the region EO ESG. Traffic originating from region BO VMs agrees the local network to the region BO ESG. Traffic between VMs utilize the Universal Distributed Logical Router for east-west optimization. Let's review perimeter gateway configuration. Here's the configuration of region AO perimeter gateway Edge Services Gateway. Here are two utilized NIC. Virtual NIC O is configured with the addresses in the subnet of the region AO uplink network. It is connected to the VLAN-backed port group ESXi region AO1 VDS comp. The type of interface is an uplink, typically provide update to the data center's physical routing infrastructure. Virtual NIC 1 is configured with an address in the subnet of region AO transit network. It is connected to the Universal Logical Switch region AO transit. The type of the interface is internal and, in this case, connected downstream to the logical switch shared by Universal Distributed Logical Router. On the Routing tab, you can see that ECMP and BGP have been pre-configured on each Edge Services gateways. The Edge Services gateways has neighbors configured for 109.168.101, which is the upstream router, as well as 192.168.53, which is the Universal Logical Distributor router. Let's check this configuration on the secondary NSX manager for region BO perimeter gateway. Now let's see Universal Distributed Logical Router configuration. Note that logical egress is enabled. This can only be enabled during the configuration of Universal Logical Distributed Router. And note that the Universal Distributed Logical Router appliance is deployed from region AO1. You can see there are two uplink interfaces configured. The region AO uplink interface is configured on the primary NSX manager Universal Distributed Logical Router. The region BO uplink interface is configured on the secondary NSX manager Universal Distributed Logical Router. The internal interfaces are configured on the primary NSX manager. The configuration of the Universal Distributed Logical Router is synchronized with the secondary NSX manager. I will now set the local ID on region BO to the local ID of region AO. Setting the local ID same on the both sides will ensure that the north-south traffic is always entering and exiting out of the protected site. Local ID is configured per cluster. The local ID allows the Universal Logical Distributed Router to make a routing decision based on the site. On the Installation tab Host Preparation, I will change the local ID for region BO to match same ID with region BA. Each NSX manager has a local ID. By default, it is set to the NSX manager UEID. This setting can be overwritten at the Universal Logical Router cluster or host level. You can easily find local ID on each NSX manager on the Summary tab. You can copy this and do in exactly what I'm doing right now. Now we will configure a Bgp Route Filter on the perimeter gateway in the recovery site region BO to deny route advertisement for web app and DB networks out of the recovery site region BO. Navigate to routing options and edit BGP neighbor settings. We will add BGP filters for neighbor. The BGP filter on Edge gateway will block the publishing of 172.16.10.0, 172.16.20.0, and 172.16.30.0 subnets to external router. So direction is out, action is deny, network is 172.16.10.0/24, and press OK. I will add same deny rule for rest 2 networks. But we also need a permit rule. Destination is out, action is permit, network is 192.168.200.0/24, and OK. That's the permit for the sites B uplink. Publish change. Now it's time to configure BGP on Universal Logical Distributor Router on primary NSX Manager. Navigate to the Universal Distributor Logical Router and edit the routing. We need to edit dynamic routing configuration. First, the router ID is required setting for dynamic routing. The routing ID is unique value that identifies the router in the routing table. This is normally an IP address configured on the router. Go to BGP section to enable BGP. BGP must be enabled and the local autonomous system must be configured. AS is configured globally on the ESG on Distributed Logical Router and Universal Distributed Logical Router. I will set 65001 as local AS. Now add a neighbor. Add the region AO perimeter gateway as a neighbor. The IP address is the IP of the internal interface or the region AO perimeter gateway. The forwarding address is the IP address of the Universal Distributed Logical Router region AO uplink interface. The protocol address is an unused IP address in the same network as the forwarding address. The forwarding address is used as the data plane, while the protocol address is used the control plane. For remote AS set 65001. Publish changes. Route distribution must be enabled on the Universal Logical Distributed Router for connected network to be advertised via BGP. So select BGP and click OK. OSPF is not configured in this environment and should be disabled. A new distribution criteria must be added for BGP to learn connected interfaces. Publish changes. We are finished configuration of internal BGP between Universal Distributed Logical Router in region AO and Edge Gateway in region AO. Now let's enable BGP on Universal Logical Router region BO for dynamic routing. The router ID is a required setting for dynamic routing. The router ID is unique value that identifies the router in the routing table. This is normally an IP address configured on the router. Select region BO uplink as the router ID. First, publish changes. then goes to configure Universal Logical Distributed Router for BGP. BGP must be enabled and the region BO perimeter gateway must be added as a neighbor. I will set 65011 as local AS. Add a neighbor. Add the region AO perimeter gateway as a neighbor. The IP address is the IP of the internal interface or of the region A perimeter gateway. The forwarding address is the IP address of the Universal Distributed Logical Router region AO uplink interface. The protocol address is an unused IP address in the same network as the forwarding IP address. In remote AS field, I will enter 65011. Publish changes. Route distribution must be enabled on a Universal Logical Distributed Router for connected network to be advertised via BGP. Check only BGP. OSPF is not configured in this environment and should be disabled. A new redistribution criteria must be added for BGP to learn connected interfaces. Publish change. For now we are finished our tasks. We have successfully configured internal BGP peering of Universal Distributed Logical Router in region BO to Edge Gateway in region BO. Now let's verify application connectivity. Open the web browser and 3-tier app. Here is the customer DB app page. So multi-tier application page is loaded and the data is retrieved. Let's use command prompt on the main console to ping VMs. I will ping each virtual machine. All pings was successful, but we didn't touch any firewall rules. So let's create universal distributed firewall rules. We will now create universal distributed firewall rules for customer DB application, AP sets, MAC addresses or MAC sets. Now we will create IP set for application tiers. Actually we need to create 3 IP sets. For web tier, app tier and DB tier. I will name this web tier. IP address will be 172.16.10.0/24. Check the option mark this object for universal synchronization and click OK. I will do same for 2 REST IP tier, of course with different IP addresses. Take a look at secondary NSX Manager. Here's our new 3 IP sets on secondary NSX Manager. As soon as we create the IP set on primary NSX Manager, the Universal Synchronization Service will push the rules to the secondary NSX Manager. It is important to validate that the synchronization is taking place across both NSX Manager. Go to Firewall tab. Navigate to Distributed Firewall Configuration page and add section to the firewall rule set. I will call this section 3-tier up. Check mark this section for universal synchronization. Now let's add a universal rule in tier up section and configure a rule for web server access. I will name the rule inbound web server. And configure a rule for web server access. For this rule we will leave this source column set to any. However, we will modify the destination for a specific IP set of addresses. For object type, select security group, and we will create one security group right here. I will call this Web Universal Security Group. And will include the web tier IP set we had created earlier. Now configure services for the rule. We need to find HTTP and HTTPS. Now let's configure a rule for Web to Application Server under previous rule. I will give the name Web to App. Set the source for the rule. Select the Web Universal Security Group. We have created this previously. And now configure Destination Security Group. The previously created IP set corresponding to App tier will be used to create the destination security. I will call this App Universal Security Group and will be include IP set App tier. We need to configure services for the rule. Select Tomcat. Add one new rule for application to database error. I will call this rule app2db. Source will be App Universal Security Group. A destination will be New Security Group. I will name this group DB Universal Security Group, which include IP set DB tier. Configure services. That will be MySQL. Last we need to do is configure default rule to reject every other traffic. Name the default rule. Leave all defaults, only change action. This rule will block all other traffic except traffic we defined earlier. Change action to reject. Publish change. And let's verify again application connectivity. Application working as well. Open a command prompt to ping each virtual machine. Ping each machine should verify the default deny rule. As we expected, no successful pings. We are finished first part of this video. In the second part of this video we will learn how to configure the important Site Recovery Manager components such as protection groups, folder mapping, resources mapping, recovery plan, etc. In addition to configuring those various components, we will perform partial failover and full failover of the application. Stay tuned. Thanks for watching.